which is called Horizontal Federated Learning. And in Horizontal Federated Learning, we use local data sets, or Horizontal Federated Learning uses local data sets that actually are subsets of some underlying global data set, or underlying global data set. And the devices, the nodes in the federated learning network, have access only to different subsets of these data points. However, they have access to all features of each data point, but different subsets of data points. And these subsets might be overlapping. So where could horizontal federated learning be used? For example, in healthcare. Think of a local data set. One of these D1 is the patient database in Helsinki, whose hospital. Another local data set is the Allgemeine Krankenhaus in Vienna, so a hospital in Vienna. And let's say that's somewhat standardized what they measure. So they use the same features. In Finland and in Austria, they measure blood pressure, temperature, height, weight. So it's pretty similar. As I can say from my own experience, it's pretty similar, the experience when you go to a doctor in Helsinki and in Vienna. They measure pretty much the same. But they typically measure different populations. So not everybody was in Vienna and in Helsinki. So I might be one of these few in the overlap between D1 and DI. Okay, so that's my main example for horizontal federated learning. I've also listed here some others from finance, condition monitoring, smart grids, and restaurants. And I mean, we can use horizontal federated learning, or horizontal federated learning means a specific way or corresponds to a specific choice for these loss functions. In particular, these loss functions are the average loss on these local data sets. And these local data sets, they are partially overlapping. And here we could also use a specific choice for the edge weights. I mean, it seems natural to train similar model for two hospitals. Let's say these two local data sets are two hospitals. If they have many patients in common. So if they have many common patients, then we might train a similar predictive healthcare model. If two hospitals have records about very different populations, they might not want to train a similar predictive healthcare model. So in horizontal federated learning, we might use this overlap of the local data sets as a measure or as a choice for the edge weights. So in horizontal federated learning, we use the overlaps of local data sets to construct the edge weights. And we put larger edge weights between two local data sets if they have many data points in common. Okay. Any questions at this point? So horizontal federated learning seems rather straightforward. We just use different subsets of data points, but all local data sets use the same sets of features. Okay. Yeah, and this might also be one way to construct the edge weights in your project. So if you find in your project the federated learning application is actually a horizontal federated learning application, then you could say I choose edge weights based on the overlaps of these data sets. And you can also use variations here. I mean, instead of just counting how many data points two local data sets have in common, you could also use more coarse statistics of the data sets. Like you could say, if this data set has 60% more female patients, and another data set also has this split 60% female patients, then you consider them similar. So you can use these statistics of certain features or labels, or the relative distributions of labels or features as an indicator for putting an edge between two local data sets. Or, for example, you would have one hospital has 90% patients being children under below 10 years. And another data set would also have mostly children as patients. I mean, of course, this would be maybe clear at first because they are both pediatric hospitals. So then you would say, okay, they are more similar than general hospitals or hospitals specialized for females or elderly people. But instead of directly implementing this or enforcing these similarities, you could read it from the data. So you could say, based on the frequency of a certain disease in this healthcare provider and that healthcare provider, we consider them similar or not similar. Okay, there's a question. Several questions, actually. What should we do if nodes have all the features, but there's no common subset among them? I mean, fully non-IID, how to aggregate the local models? Yes, good point. Yeah, what I just said, not using the intersection of these local data sets, but just the statistics. This is one way. So you can compare the statistics of two local data sets, even if they have no data points in common. This would be one way. Also to avoid coupling two nodes that have very different distributions. I mean, this statistics of what disease or age groups is one way to characterize the statistical distribution. Another question, is there a way to measure how much two data sets are similar, the amount of overlap in a privacy-preserving fashion? Yeah, very good point. So I don't know actually how to compute the overlap between two hospitals in a most privacy-friendly way. They would need to know something about the other hospital's patients in order to find out if they have common patients. But how to do this in a most privacy-friendly way, I don't know. And I would say this is also beyond the scope of the student project. But if you do it and if you discuss it and explain it, then this would be excellent, of course. Very good point. Yeah, it's important to not overlook this privacy leakage that doesn't occur in the actual federated learning algorithm, which is, for example, a distributed optimization method solving this GTVMin, but already at the step where you construct this optimization problem, where you construct the edge weights. You must be careful not already there in these pre-processing steps to leak private information. For example, here, when you want to construct the edge weights based on the overlap, I mean, one trivial way would be each hospital shares its full patient database with the other hospital. And then you can determine this overlap easily, but then you might have leaked too much privacy. Okay, another question here. Yeah, in this example, one node in the federated learning network could represent one hospital. And then you have a network of different hospitals. For example, all hospitals across Europe, all pediatric hospitals across Europe. The next question, is there any difference between aggregation methods in horizontal and vertical federated learning? Yeah, I will discuss vertical federated learning in a second. They are different, yes. Next question, for the weights of the edges, there is no limitation. Can we consider different ways to construct the edge weights? Yes. So this is an important design choice, how you choose these edge weights. First of all, where to place edges between which nodes and how large the edge weight is. And this is a design choice, and you can try out two different constructions for these edge weights, and you get two different federated learning methods, strictly speaking.